Picture this. You're standing in your backyard on a clear night, gazing up at that faint ribbon of light stretching across the darkness. The Milky Way, our cosmic home. For over a century, astronomers have been measuring it, mapping it, trying to understand just how big this magnificent spiral really is. And for over a century, we've been getting it spectacularly wrong. Just this year, a groundbreaking discovery has shattered everything we thought we knew about our galaxy's size. The numbers aren't just a little off. They're so dramatically different that it's forcing us to rewrite the textbooks and reconsider our place in the cosmic landscape entirely. We're not talking about a small correction here. We're talking about a revelation that makes the Milky Way nearly twice as large as we previously believed, with implications that ripple through every corner of astrophysics. But before we dive into this revolutionary discovery, we need to understand why measuring our own galaxy has always been one of astronomy's greatest challenges. Imagine trying to measure the size of a vast forest while you're standing somewhere deep in the middle of it. That's essentially what astronomers have been attempting to do with the Milky Way for generations. Unlike distant galaxies that we can observe from the outside, seeing their full structure laid out before us like cosmic pinwheels against the velvet of space, we're embedded right inside our own galaxy. We're about 26,000 light years from the centre, sitting in what astronomers call the Galactic disk, surrounded by billions of stars, clouds of gas and dust, and all the cosmic debris that makes up a living, breathing spiral galaxy. This presents a fundamental observational challenge. When you look up at the night sky and see that misty band of the Milky Way stretching from horizon to horizon, you're actually looking edge-on through the disk of our galaxy. It's like trying to understand the layout of a city while standing on a busy street corner, surrounded by buildings that block your view in every direction. For decades, astronomers have been using clever workarounds to tackle this problem. They've studied the distribution of stars at different distances, analysed the light from various stellar populations, and developed sophisticated mathematical models to extrapolate what the galaxy might look like from the outside. But every method came with its own set of assumptions, its own built-in biases, and its own potential for systematic error. The traditional approach relied heavily on something called the exponential disk model. This elegant mathematical framework assumed that stellar density decreases smoothly and predictably as you move away from the galactic centre, following a simple exponential curve. It was neat, it was tidy, and it made the calculations manageable. But as we'll discover, nature rarely cooperates with our desire for mathematical simplicity. The exponential model introduced a concept called scale length, which became the standard way of characterizing galactic size. Think of scale length as asking a simple question. How quickly does the number of stars drop off as you move away from the galaxy's bright central regions? For the Milky Way, these scale length measurements painted a picture of a surprisingly compact galaxy. The numbers suggested our cosmic home was much smaller and more tightly packed than other spiral galaxies of similar mass. This created what astronomers began calling the Milky Way size problem. Here's where things get fascinating from a scientific perspective. When you compare galaxies across the universe, you expect to see certain relationships. Galaxies of similar mass should have roughly similar sizes. It's like expecting that cities with similar populations should occupy roughly similar areas. But the Milky Way seemed to be breaking this cosmic rule. According to the traditional measurements, our galaxy appeared to be what astronomers diplomatically called an outlier. In less diplomatic terms, it looked like a cosmic weirdo. Among galaxies of comparable mass, the Milky Way ranked in the bottom 5% for size. It was as if our galaxy had somehow failed to grow to its expected dimensions, remaining mysteriously compact while its cosmic siblings stretched out across much larger regions of space. This puzzling result forced astronomers into theoretical contortions. Why would the Milky Way be so different? Had it experienced some unusual evolutionary history? Was there something fundamentally different about how it formed or how it accumulated mass over the billions of years since the universe's youth? Some proposed that our galaxy had undergone particularly efficient star formation, packing more stellar mass into a smaller volume. Others suggested that interactions with neighbouring galaxies might have somehow compressed our cosmic home. But none of these explanations felt entirely satisfying. The Milky Way didn't just seem a little unusual, it appeared to be profoundly anomalous. Enter a revolutionary study published in 2024 that would change everything. Led by researchers using data from the Apache Point Observatory Galactic Evolution Experiment, this investigation took a fundamentally different approach to measuring galactic size. Instead of relying on the traditional scale-length method, the team employed something called the half-light radius. This might sound like a technical detail, but it represents a philosophical shift in how we think about galactic dimensions. The half-light radius asks a beautifully simple question. How far do you need to go from the galaxy's centre before you've enclosed exactly half of all the light it produces? This approach had been widely used for studying distant galaxies where astronomers could see the full extent of the stellar distribution, but applying it to our own galaxy required overcoming that fundamental challenge we discussed earlier. How do you get an objective view of something when you're stuck inside it? The research team found their answer in an unlikely stellar population: red giant stars. These are stars that have entered a particular phase of their evolutionary journey, expanding to enormous sizes and shining with tremendous brightness. More importantly for the astronomers, red giants emit strongly in infrared light, which can penetrate through the dust and gas that normally obscures our view of distant parts of the galaxy. Using infrared observations, the team could effectively see through the cosmic fog that had been limiting previous studies. They mapped red giant stars across an unprecedented range of distances, from the galaxy's centre all the way out to its far reaches, building the most complete picture of the Milky Way's stellar distribution ever assembled. What they discovered was nothing short of revolutionary. The careful analysis revealed that the Milky Way's stellar distribution doesn't follow the smooth exponential decline that astronomers had assumed for so long. Instead, the galaxy shows what's called a broken profile, with a nearly flat distribution of stars extending much further than anyone had expected. The numbers tell the story. Instead of the compact 3.4 kiloparsec half-light radius suggested by traditional methods, the new analysis revealed a half-light radius of 5.75 kiloparsecs. To put that in perspective, we're talking about the difference between roughly 11,000 light-years and nearly 19,000 light-years. The Milky Way had suddenly grown by almost 70% in our understanding. But the implications go far beyond just updating a number in a textbook. This discovery means that the Milky Way isn't the cosmic oddball we thought it was. Instead of being unusually compact, our galaxy turns out to be perfectly normal for a spiral of its mass. The size problem that had puzzled astronomers for decades simply evaporated. Dr. Gail Zasowski, one of the researchers involved in the study, captured the significance beautifully. For decades, evidence has told us that the Milky Way is a little bit of a weirdo as far as galaxies go. Our disk was much more compact than many other spiral galaxies we've studied, so the Milky Way may be more normal in terms of its physical size for its mass. This normalization of the Milky Way has profound implications that ripple through multiple areas of astrophysics. Models of galaxy formation and evolution had been struggling to explain why our galaxy appeared so anomalous. Theoretical frameworks had to incorporate special conditions or unusual processes to account for the Milky Way's apparent compactness. Suddenly, all of those complex explanations became unnecessary. The revelations didn't stop with size. The new understanding of the galaxy's structure led to another shocking discovery. We'd been dramatically overestimating the total mass of stars in the Milky Way. The traditional exponential model, when extrapolated inward to estimate the total stellar content, suggested a disk mass of over 40 billion times the mass of our Sun. But the new, more accurate profile painted a very different picture. The actual stellar mass appeared to be less than half of previous estimates, dropping to around 20 billion solar masses. This represents one of the most significant corrections to our understanding of the Milky Way's fundamental properties in modern astronomy. Think about what this means. For years, astronomers have been building models of galactic evolution, star formation rates, and chemical enrichment based on a stellar mass that was off by more than a factor of 2. The error arose from a seemingly reasonable assumption. Since detailed observations of the inner galaxy were challenging due to dust obscuration and the brightness of the galactic center, astronomers had been extrapolating inward from measurements of the outer disk. They assumed the exponential profile observed in the outer regions continued smoothly all the way to the center, but the new observations revealed that this extrapolation was fundamentally flawed. The inner galaxy doesn't follow the same density distribution as the outer regions. Instead, it shows a much flatter profile, with stellar density remaining roughly constant across a large central region before beginning to decline in the outer disk. These discoveries are sending shockwaves through the astronomical community, forcing researchers to reconsider everything from dark matter distribution to galaxy formation models. When you change the fundamental parameters of the most well-studied galaxy in the universe, the one that serves as a template for understanding all other galaxies, the effects cascade through every corner of the field. Consider the implications for our understanding of dark matter. The Milky Way sits embedded in a vast halo of dark matter that extends far beyond the visible stars. Models of this dark matter distribution have been calibrated based on the galaxy's gravitational effects and the motion of stars and gas throughout the disk. If the stellar mass is significantly lower than previously thought, it changes the balance between visible and dark matter. It affects our understanding of how efficiently the galaxy converts gas into stars, how much mass remains locked up in dark matter, and how the galaxy's gravitational influence extends into its surroundings. The revision also impacts our understanding of the local group, the small cluster of galaxies that includes the Milky Way, Andromeda, and dozens of smaller companions. The gravitational dance between these galaxies depends critically on their masses and sizes. A less massive, but more extended Milky Way changes the dynamics of this cosmic neighborhood in subtle but important ways. Behind this revolutionary discovery lies a story of technological advancement that's equally fascinating. The breakthrough was made possible by the European Space Agency's Gaia spacecraft, which has been systematically mapping the positions, distances, and motions of over 1 billion stars in our galaxy. Gaia represents one of the most ambitious scientific projects ever undertaken. Launched in 2013, this spacecraft has been creating the most precise, three-dimensional map of the Milky Way ever imagined. Its measurements are so accurate that it can detect stellar motions equivalent to watching a human hair grow from the distance of the Moon. This precision has revolutionized our ability to study galactic structure. Before Gaia, astronomers had reliable distance measurements to perhaps a few million stars. Gaia has expanded that number to over 1 billion, increasing the measurable volume of space by a factor of 100 in radius, and improving precision by a factor of 1,000. The Apache Point Observatory Galactic Evolution Experiment, which provided the crucial data for the size revision, builds on Gaia's foundation by adding detailed chemical and physical information about hundreds of thousands of stars. Operating in the near-infrared spectrum, Apogee can peer through the dusty regions of the galaxy that block visible light, providing a clear view of stellar populations throughout the galactic disk. This technological revolution continues to unfold. As more data becomes available and analysis techniques become more sophisticated, we can expect further surprises about the structure and properties of our cosmic home. The story of the Milky Way's size is far from over, but there's an even more profound question lurking beneath these discoveries, one that touches on the very nature of scientific knowledge and our place in the universe. If we could be so wrong about something as fundamental as the size of our own galaxy, what other cosmic assumptions might be built on shaky foundations? The revelations about our galaxy's size were just the beginning. As astronomers delved deeper into the data, they uncovered something even more extraordinary lurking at the edges of our cosmic home. Far beyond where the traditional models said the Milky Way should end, they found something that challenged our very definition of where a galaxy begins and where it stops. In the outer reaches of our galactic disk, at distances that should have been empty space according to conventional wisdom, astronomers discovered vast streams and rings of stars. These weren't random collections of cosmic debris. They were organized structures following patterns that suggested they were integral parts of our galaxy's architecture. The first of these mysterious structures was dubbed the Monoceros Ring, named after the constellation where it was initially detected. This isn't just a small collection of wayward stars. We're talking about a structure containing 100 million times the mass of our Sun, stretching across 200,000 light-years of space, and wrapping around our entire galaxy not once, not twice, but 3 complete times. When this ring was first discovered in 2002, it sparked intense debate. Was this the remnant of a smaller galaxy that had been torn apart by the Milky Way's gravitational forces? Or was it something more profound, evidence that our galaxy's disk extends much further into space than anyone had imagined? The discovery didn't stop there. Astronomers soon found additional structures even further out. The Triangulum Andromeda Stream, lying roughly 80,000 light-years from the galactic centre, in regions where conventional models predicted virtually no stars should exist. Each new discovery pushed the apparent boundaries of our galaxy further into what had previously been considered empty space. But here's where the story takes a fascinating turn. These distant structures weren't scattered randomly around our galaxy. They showed a peculiar pattern that seemed almost too organised to be coincidental. The structures appeared to be spaced roughly 6,000 light-years apart from each other, like cosmic mile markers stretching into the void. Even more intriguingly, they alternated in their vertical position relative to the galactic disk. The first structure sat above the disk plane, the next below it, then above again, then below, creating what astronomers began calling a corrugated pattern. like ripples in a cosmic sheet of cardboard. This regular spacing and alternating pattern suggested something remarkable. These weren't random debris fields, but evidence of large-scale gravitational waves that had somehow propagated through our galaxy's structure. Something had disturbed the Milky Way on a grand scale, creating oscillations that extended far beyond the traditional galactic boundary. These discoveries forced astronomers to confront a fundamental question that had been lurking at the edges of galactic astronomy for decades. Where exactly does a galaxy end? It sounds like it should be a straightforward question, but the answer turns out to be surprisingly complex and philosophically profound. Traditional definitions focused on the visible stellar disk, the pancake-shaped collection of stars that contains most of a galaxy's luminous matter. By this definition, the Milky Way extended roughly 100,000 light-years from edge to edge. It was a neat, tidy boundary that made calculations manageable and fit comfortably in textbooks. But the discovery of these extended structures suggested a very different picture. If the Monoceros ring and the triangulum Andromeda stream are truly part of our galaxy's disk, then the Milky Way suddenly becomes 60% larger than previously thought, stretching nearly 160,000 light-years across. This expansion brings our galaxy into close competition with our nearest large neighbour, the Andromeda Galaxy. For decades, Andromeda had been considered the clearly dominant member of our local group of galaxies, significantly larger and more massive than the Milky Way. But these new discoveries suggest our cosmic home might be more of an equal partner in this galactic dance. Yet even this expanded definition pales in comparison to what happens when you consider the full extent of a galaxy's gravitational influence. Recent studies using computer simulations and observations of satellite galaxies have revealed that the Milky Way's dark matter halo, the invisible scaffolding that dominates the galaxy's mass, extends nearly 2 million light-years from the galactic centre. At these vast distances, the boundary isn't marked by visible stars or glowing gas clouds. Instead, it's defined by the subtle gravitational choreography of small galaxies orbiting our cosmic neighbourhood. These satellite galaxies move in predictable patterns until they reach a critical distance, about 950,000 light-years from the Milky Way's centre, where their motions suddenly change, marking the edge of our galaxy's gravitational dominance. This creates a layered definition of galactic size that depends entirely on what you're measuring. The luminous stellar disk extends roughly 80,000 light-years from the centre. The extended stellar structures push that boundary to perhaps 160,000 light-years. But the full gravitational influence of our galaxy reaches nearly 2 million light-years into space, a sphere so vast that light takes over 6 million years to cross it. Behind all of these discoveries lies one of the most ambitious scientific projects ever undertaken: the systematic cataloguing of individual stars across our galaxy. This might sound like the cosmic equivalent of counting grains of sand on a beach, but it represents a fundamental shift in how we study galactic structure. For most of astronomical history, we've been forced to study galaxies as statistical entities, measuring their overall brightness, estimating their total mass, and inferring their structure from limited samples. But modern technology has made possible something that would have seemed like science fiction just a few decades ago: creating a detailed census of individual stars across vast regions of our galaxy. The European Space Agency's Gaia mission stands at the forefront of this revolution. This remarkable spacecraft has been systematically measuring the positions, distances, brightnesses, and motions of over 1 billion stars, roughly 1% of all the stars in our galaxy. To put this achievement in perspective, Gaia has expanded our detailed knowledge of stellar positions by a factor of 500 compared to what was available just 2 decades ago. The precision achieved by Gaia is almost incomprehensible. The spacecraft can measure stellar positions to an accuracy of micro-arc seconds, roughly equivalent to measuring the width of a human hair at the distance of the Moon. This precision allows astronomers to detect the tiny parallax shifts that reveal stellar distances, creating the first truly three-dimensional map of our galactic neighborhood. But Gaia's measurements go beyond simple position and distance. The spacecraft also tracks how stars move through space, recording proper motions that reveal the complex gravitational choreography governing our galaxy's structure. These motion measurements have unveiled streams of stars moving together through space, the fossil remnants of smaller galaxies that were consumed by the Milky Way billions of years ago. The Apache Point Observatory Galactic Evolution experiment adds another crucial layer to this stellar census. While Gaia provides the fundamental astrometric framework, Apogee conducts detailed spectroscopic analysis of hundreds of thousands of stars, revealing their chemical compositions, temperatures, and evolutionary stages. This combination of precise distances and detailed stellar properties has revolutionized our ability to study galactic archaeology, using the chemical fingerprints and motions of individual stars to reconstruct the history of our galaxy's formation and evolution. Each star becomes a time capsule, carrying information about the conditions that existed when and where it formed. Perhaps the most profound implication of these size revisions involves something we can't directly see: the dark matter that dominates our galaxy's mass. For decades, astronomers have known that the visible stars and gas in galaxies account for only a small fraction of their total gravitational mass. The rest, roughly 85% of all matter in the universe, consists of mysterious dark matter that interacts gravitationally but remains invisible to our telescopes. The traditional view of the Milky Way as a compact galaxy created a puzzle for dark matter theorists. Computer simulations of galaxy formation in a dark matter-dominated universe predicted that galaxies like ours should have extended stellar disks supported by massive dark matter halos. But if the Milky Way was unusually compact, it suggested either that our galaxy had an unusual formation history or that our understanding of dark matter physics was incomplete. The discovery that our galaxy is actually much larger and more normal than previously thought resolves this tension in elegant fashion. The extended stellar structures we've been finding at large distances are exactly what theoretical models predicted should exist in the outer regions of dark matter halos. This alignment between observation and theory provides crucial support for our understanding of cosmic structure formation. It suggests that the Milky Way formed through the same processes that created other spiral galaxies throughout the universe, gradually accumulating mass through the merger of smaller systems, all orchestrated by the invisible gravitational scaffolding of dark matter. But the dark matter story introduces another layer of complexity to the question of galactic size. The stellar disk that we can observe directly extends perhaps 80,000 light-years from the galactic center. The dark matter halo that supports this disk extends roughly 25 times further, nearly 2 million light-years into space. This creates a nested hierarchy of galactic boundaries. The bright central bulge extends only a few thousand light-years from the center. The main stellar disk reaches roughly 50,000 light-years. The extended stellar structures push the boundary to perhaps 160,000 light-years. But the full dark matter halo, The gravitational foundation that makes all of this possible extends into a realm so vast that it nearly touches the halos of our neighbouring galaxies. These discoveries are forcing astronomers to reconsider fundamental questions about how galaxies grow and evolve over cosmic time. The traditional picture suggested that the Milky Way had somehow failed to reach its expected size, remaining mysteriously compact while similar galaxies expanded to larger dimensions. But the new understanding reveals a very different story. Our galaxy appears to have followed the standard evolutionary pathway predicted by theoretical models. It began as a small collection of gas and dark matter in the early universe, gradually accumulating mass through the merger of smaller systems and the accretion of intergalactic material. The complex structure we observe today, the central bulge, the spiral arms, the extended outer disk, the stellar halo, all reflect different phases of this evolutionary history. The oldest stars formed when our galaxy was still a collection of smaller fragments. The disk structure emerged as these fragments settled into a rotating configuration. The spiral pattern developed through gravitational instabilities and interactions with neighbouring galaxies. The extended stellar structures at large distances likely represent the most recent chapters in this evolutionary story. They may be the tidal remnants of small galaxies that were disrupted as they fell into the Milky Way's gravitational well, or they could be evidence of large-scale disturbances that propagated through our galaxy's disk during close encounters with massive neighbours. This evolutionary perspective reveals the Milky Way as a dynamic, constantly changing system rather than a static collection of stars. Over the billions of years since its formation, our galaxy has been shaped by countless interactions, mergers, and internal processes. The structure we observe today represents just a single snapshot in an ongoing cosmic drama. The implications extend beyond our own galaxy to our understanding of spiral galaxies throughout the universe. The Milky Way serves as the template for interpreting observations of distant galaxies, where we can see overall structure but cannot resolve individual stars. If we've been systematically misunderstanding the structure of our own galaxy, it raises questions about how accurately we've been interpreting observations of other spiral systems. Despite these revolutionary discoveries, the challenge of measuring our galaxy's true extent continues to evolve. Each new observational capability reveals additional layers of structure that were previously invisible, forcing astronomers to continually refine their understanding of where our cosmic home begins and ends. The next generation of astronomical surveys promises to push these boundaries even further. Projects like the Vera Rubin Observatory will systematically map the sky in unprecedented detail, potentially discovering new stellar streams and structures at even greater distances from the galactic centre. Space-based telescopes operating in infrared wavelengths will peer through the dust that obscures much of our galaxy's structure, revealing stellar populations that remain hidden from ground-based observations. These missions may uncover additional evidence for extended stellar disks or reveal entirely new components of galactic architecture. Perhaps most intriguingly, future gravitational wave detectors may provide an entirely new window into galactic structure. As these instruments become more sensitive, they may be able to detect the gravitational signatures of large-scale mass distributions within our galaxy, providing a completely independent method for measuring galactic extent and structure. The story of the Milky Way's size serves as a powerful reminder of how much we still don't know about our cosmic neighbourhood. Despite being the galaxy we can study in the greatest detail, it continues to surprise us with new discoveries that challenge our fundamental assumptions about galactic structure and evolution. Each revelation opens new questions that will drive astronomical research for decades to come. How many more stellar streams and extended structures remain to be discovered? What do these features tell us about our galaxy's formation history? How do they connect to the broader story of cosmic structure formation? But perhaps the most profound lesson from this ongoing revolution in our understanding is more philosophical than scientific. It reminds us that even our most basic assumptions about the universe around us may be built on incomplete foundations, waiting to be overturned by the next generation of observations and discoveries. The Milky Way that seems so familiar, so well understood, has revealed itself to be far stranger and more complex than we ever imagined. And if we can be so wrong about something as fundamental as the size of our own cosmic home, it makes you wonder what other surprises the universe has in store for us. As we stand at the precipice of this galactic revelation, something curious begins to emerge from the data. The more precisely we measure our cosmic home, the more it seems to resist simple definition. The boundaries shift, the structures multiply, and what once appeared solid becomes fluid. It's as if the very act of observation changes what we're observing. This brings us to a fascinating intersection between the vast and the intimate, between the cosmic and the quantum, where the tools we use to measure the universe might be fundamentally altering our understanding of it. When we peer into the depths of space with our most sensitive instruments, we're not just passively recording what's there. We're engaging in an active dialogue with the cosmos itself. Consider the profound implications of what we've discovered. For decades, our galaxy appeared to be an anomaly, a cosmic outlier that refused to fit the patterns we expected. But the moment we changed how we looked, shifting from scale length to half-light radius, from visible light to infrared, from statistical models to individual stellar census, suddenly everything fell into place. The Milky Way transformed from weird to wonderfully normal. This isn't just about better technology or more precise measurements, though those certainly played their part. It's about something deeper, the recognition that reality might be far more dependent on the perspective of the observer than we ever imagined. The galaxy didn't change. Our way of seeing it did. And in that shift of perspective, an entirely new universe revealed itself. In the quantum world, physicists have long grappled with the observer effect, the idea that the act of measurement fundamentally alters what's being measured. An electron doesn't have a definite position until we try to find it. A photon doesn't choose its path until we force it to reveal which way it went. The very foundation of quantum mechanics rests on this strange relationship between consciousness and reality. But what if this principle extends far beyond the atomic realm? What if the same mysterious connection between observer and observed that governs subatomic particles also shapes our understanding of galactic structure? Some interpretations suggest that consciousness and cosmos might be more intimately connected than our materialist worldview typically allows. When the Gaia spacecraft began its systematic survey of stellar positions, measuring over 1 billion stars with unprecedented precision, it wasn't just cataloguing what was already there. It was participating in the ongoing definition of what there actually means. This remains speculative territory, of course, far from any scientific consensus. But the parallels are intriguing. Just as quantum particles seem to exist in states of superposition until measured, perhaps our galaxy existed in a kind of structural superposition, simultaneously compact and extended, anomalous and normal, until we developed the observational tools to collapse that uncertainty into definite knowledge. The meditation masters of ancient traditions spoke of a similar principle in the realm of consciousness. They suggested that reality isn't something we simply discover, but something we continuously participate in creating through the quality of our attention. When we observe with calm, patient awareness, they claimed, new layers of truth naturally reveal themselves. There's something almost meditative about the concept of a stellar parallax, the technique that allows us to measure distances to nearby stars. As Earth orbits the Sun, our perspective shifts slightly, causing nearby stars to appear to move against the backdrop of more distant ones. It's the same principle that makes objects outside a car window appear to shift position as you drive past. But achieving this cosmic parallax requires extraordinary patience. You must wait 6 months for Earth to move to the opposite side of its orbit, then measure stellar positions with micro-arc-second precision, detecting movements so tiny they're like watching a coin on the moon wobble by the width of a human hair. This patience, this willingness to wait for perspective to shift naturally, mirrors something fundamental about contemplative practice. The deepest insights rarely arrive through force or hurry. They emerge when we learn to rest in uncertainty, to observe without immediately trying to categorize or explain, to let reality reveal itself in its own time. The astronomers who discovered our galaxy's true size weren't trying to revolutionize cosmology. They were simply practicing a kind of cosmic mindfulness, patiently gathering data, carefully observing, allowing the evidence to accumulate naturally. They created space for surprise, for the universe to be different than they expected. In meditation traditions, there's a concept called beginner's mind, approaching experience with fresh eyes, free from preconceptions about what should be there. The researchers who measured the Milky Way's extended structures embodied this principle perfectly. They looked at familiar stellar populations with new instruments and discovered that home was far stranger and more beautiful than anyone had imagined. The discovery of the galaxy's corrugated structure, those alternating ripples above and below the galactic disk, reveals something that almost resembles breathing on a cosmic scale. These aren't static features frozen in time. They're evidence of dynamic processes, gravitational waves that have propagated through our galaxy's structure, like breath moving through a vast cosmic body. Something disturbed the Milky Way long ago, perhaps the passage of a satellite galaxy or the influence of dark matter streams. That disturbance sent waves rippling outward, creating the regular pattern of stellar structures we observe today. The galaxy inhaled the disruption and has been slowly exhaling its effects across billions of years. This cosmic breathing connects us to cycles that extend far beyond human timescales, yet somehow mirror the rhythms we experience in our own bodies. Each breath we take participates in the same fundamental exchange of energy and matter that shapes galactic evolution. The oxygen in our lungs was forged in the nuclear furnaces of dying stars. The carbon in our cells once drifted through interstellar space before being incorporated into the molecular machinery of life. When contemplatives speak of feeling connected to something larger than themselves, they might be touching on this literal truth. We are continuous with the cosmos at every level, from the quantum to the galactic. Our bodies are made of star stuff. Our planet orbits within the extended disk of our galaxy, and our galaxy breathes with the slow rhythm of cosmic time. There's no scientific consensus on whether this connection extends beyond the physical to include consciousness itself, but the possibility invites us to consider what it might mean to align our awareness with these deeper rhythms, to breathe with the galaxy rather than against it. Werner Heisenberg's uncertainty principle tells us that certain pairs of properties cannot be simultaneously known with perfect precision. The more accurately you know a particle's position, the less accurately you can know its momentum, and vice versa. This isn't a limitation of our measuring instruments. It's a fundamental feature of reality itself. Something remarkably similar emerges when we try to define the boundaries of our galaxy. The more precisely we try to specify where the Milky Way ends, the more uncertain that boundary becomes. Is it the edge of the luminous disk at 50,000 light-years? The extent of the stellar halo at 160,000 light-years? The boundary of gravitational influence at nearly 2 million light-years? Each definition captures something real about our galaxy's structure, but none provides the complete picture. The boundary isn't a sharp line, but a gradual transition, a zone where galaxy slowly fades into intergalactic space without any clear demarcation. It's as if the universe resists our human need for precise categories and definite boundaries. This galactic uncertainty principle might reflect something deeper about the nature of complex systems. Perhaps all boundaries, whether around galaxies, around individual consciousness, or around the self, are more fluid and contextual than we typically imagine. The edge isn't a place but a process, not a location but a relationship. Ancient wisdom traditions often spoke of this fluidity in terms of interdependence, the recognition that nothing exists in isolation, that all phenomena arise through the intersection of countless causes and conditions. Modern cosmology is discovering the same truth on galactic scales. Our galaxy doesn't exist as a separate entity, but as a node in the cosmic web, continuously exchanging matter and energy with its environment. There's something profoundly meditative about contemplating the timescales on which galaxies evolve. The stellar streams we observe today formed over hundreds of millions of years, as small galaxies were slowly torn apart by tidal forces. The corrugated disk structure we've discovered represents gravitational waves that have been propagating for billions of years, longer than complex life has existed on Earth. These cosmic processes unfold with a patience that dwarfs human timescales, yet they're not separate from the immediate present moment. Right now, as you read these words, our galaxy is continuing its slow gravitational dance with the Andromeda Galaxy, approaching at 250,000 miles per hour, yet still billions of years away from collision. Dark matter streams are flowing through our solar system, invisible currents in the cosmic ocean that surrounds us. The practice of contemplating such vast scales can induce what some traditions call cosmic consciousness, a direct recognition of our participation in something unimaginably larger than individual human life. This isn't mystical speculation, but literal truth. Every atom in your body participated in the galaxy's formation and evolution. You are not separate from these cosmic processes, but an expression of them. Some interpretations suggest that developing this cosmic perspective might actually change how we participate in the ongoing evolution of consciousness itself. If awareness is indeed fundamental to the universe, not just an emergent property of complex brains, but a basic feature of reality, then perhaps expanding our perspective to galactic scales represents a form of cosmic meditation, a way of aligning individual consciousness with the vast intelligence that organizes stellar systems and guides galactic evolution. This remains highly speculative, of course, with no scientific consensus supporting such ideas. But the possibility invites us to consider what it might mean to live from this expanded perspective, to breathe with cosmic rhythms, to find our place not just on Earth, but within the vast, slowly turning wheel of our galactic home. Perhaps the most mysterious aspect of our revised understanding of the Milky Way involves the relationship between very large and very small scales. The same technologies that revealed our galaxy's extended structure, instruments capable of measuring stellar positions to micro-arc-second precision, depend on quantum mechanical principles for their operation. The charged coupled devices in our telescopes exploit the photoelectric effect to convert individual photons into electrical signals. The atomic clocks that provide precise timing for astronomical observations rely on quantum transitions in cesium atoms. The lasers used for interferometric measurements depend on the quantum coherence of light waves. At every level, our ability to study cosmic structure rests on quantum foundations. But the connection might run deeper than mere technological dependence. Some interpretations of quantum mechanics suggest that entanglement, the mysterious connection between particles that remain correlated regardless of distance, might extend to much larger scales than previously imagined. If consciousness does play a fundamental role in quantum measurement, as some interpretations suggest, then perhaps the act of conscious observation connects us quantum mechanically to the cosmic structures we study. When Gaia measures the position of a star 10,000 light-years away, maybe something more than classical information is being exchanged. This is highly speculative territory, far from any proven scientific fact. Mainstream physics finds no evidence that macroscopic objects, like stars or galaxies, exhibit quantum entanglement. But the philosophical implications are intriguing. If we are quantum mechanically connected to the cosmos we observe, then the boundary between observer and observed becomes even more fluid than general relativity already suggests. What emerges from all these discoveries is a picture of the universe that seems almost designed for contemplation. The more carefully we observe, the more mysteries reveal themselves. The more precisely we measure, the more we discover the limitations of measurement itself. The more we learn about cosmic structure, the more we recognize how much remains unknown. This isn't a failure of science, but perhaps its deepest teaching. Reality appears to be inexhaustibly rich, always ready to surprise us with new layers of complexity and beauty. The universe seems to reward patient, careful attention with insights that transform our understanding of our place within it. The ancient contemplatives, who spoke of reality as ultimately mysterious and inexhaustible, might have been more prescient than they knew. Every answer we discover about galactic structure generates new questions. Every measurement opens doors to deeper mysteries. The cosmos appears to be structured in such a way that consciousness can never exhaust its depths. This suggests something beautiful about the relationship between mind and universe. Perhaps consciousness and cosmos co-evolve together, consciousness developing the capacity to appreciate ever greater scales of cosmic beauty, while the universe structured itself in ways that reward such appreciation. The galaxy that seemed anomalous revealed itself as perfectly normal once we learned to see it properly. If this interpretation has any validity, and it remains purely speculative, then the practice of contemplating cosmic structure might be more than just intellectual exercise. It might be a form of participation in the universe's ongoing self-discovery, consciousness serving as the universe's way of knowing itself. There's a meditation practice that emerges naturally from our new understanding of galactic structure. It begins with the recognition that you are sitting right now within the extended disk of the Milky Way, surrounded by stellar streams that stretch across hundreds of thousands of light years of space. The gravitational waves that created our galaxy's corrugated structure are still propagating through the cosmic medium that surrounds you. Dark matter particles are streaming through your body at this very moment, connecting you to the invisible scaffolding that holds our galaxy together. The elements that compose your cells were forged in stellar nucleosynthesis and scattered through space by supernova, then gradually assembled into the molecular machinery of life. You are not separate from these cosmic processes, but intimately woven into them. Your breath participates in the same exchange of matter and energy that drives stellar evolution. Your heartbeat echoes the rhythm of gravitational waves propagating across galactic distances. Your consciousness might be the universe's way of observing and appreciating its own structure. This perspective doesn't require any belief in unproven scientific claims. It's simply a recognition of the literal connections that link individual human life to galactic evolution. We are made of star stuff. We orbit within our galaxy's extended disk, and we participate through our observations in the ongoing definition of cosmic structure. From this galactic perspective, the concerns that typically dominate human consciousness, career pressures, relationship challenges, financial worries, don't disappear, but find their proper context within something unimaginably larger and more mysterious. Problems remain problems, but they're problems arising within the vast, slowly evolving story of cosmic consciousness awakening to itself. Some traditions suggest that resting in this expanded perspective naturally cultivates what they call cosmic compassion, a recognition that all beings participate in the same vast process of cosmic evolution, all consciousness emerging from the same stellar furnaces, all life depending on the same gravitational forces that organize galactic structure. As our observational capabilities continue to expand, we can expect even more dramatic revisions to our understanding of galactic structure. The next generation of telescopes will peer deeper into space and time, revealing how galaxies like ours formed and evolved over cosmic history. Space-based interferometers might detect gravitational waves from galactic-scale processes, providing entirely new windows into cosmic structure. Perhaps most intriguingly, advances in quantum technology might eventually allow us to test whether consciousness does play any fundamental role in cosmic evolution. Quantum computers operating at galactic scales might reveal new connections between information processing and cosmic structure. Experiments in quantum biology might discover quantum effects in living systems that connect biological consciousness to cosmic processes. This remains highly speculative, of course. No current evidence suggests that individual human consciousness can directly influence galactic structure, or that quantum entanglement operates on cosmic scales. But the rapid pace of discovery in both quantum physics and observational cosmology suggests that our understanding of these connections will continue to evolve in surprising ways. What seems certain is that the universe will continue to reward careful, patient observation with insights that transform our understanding of our place within it. Each generation of observers discovers that reality is stranger, more beautiful, and more mysterious than the previous generation imagined. The contemplatives, who spoke of ultimate reality as inexhaustible, might have been describing not just a spiritual truth, but a literal feature of cosmic structure. The universe appears to be organized in such a way that consciousness can never exhaust its depths, always finding new layers of complexity and beauty to explore. Perhaps the deepest teaching that emerges from our galaxy's size revision involves the recursive nature of cosmic wonder. Each answer we discover generates new questions. Each measurement reveals new mysteries. Each expansion of perspective opens onto even vaster scales of structure and beauty. The Milky Way that seemed so familiar, so well mapped, revealed itself to be twice as large as we thought, and structured in ways that nobody predicted. If we can be so wrong about something as fundamental as the size of our cosmic home, what other assumptions about reality might be ripe for revision? This isn't a cause for skepticism about scientific knowledge, but rather an invitation to approach reality with what the contemplative traditions call beginner's mind, a willingness to be surprised, to have our preconceptions overturned, to discover that the universe is always stranger and more wonderful than we imagined. The galaxy doesn't exist as a fixed object out there waiting to be discovered. It exists as a dynamic process that includes our observations of it, our theories about it, and our evolving understanding of our place within it. We don't just study galactic structure, we participate in its ongoing definition through the quality of attention we bring to cosmic observation. In this sense, astronomy becomes a contemplative practice, a way of aligning individual consciousness with the vast intelligence that organizes stellar systems and guides galactic evolution. Each careful measurement, each patient observation, each moment of wonder at the scale and beauty of cosmic structure contributes to the universe's ongoing self-discovery. The corrugated disk of our galaxy breathes with gravitational waves that have been propagating for billions of years. The stellar streams that wrap around our cosmic home carry the memory of ancient galactic encounters. The dark matter halo that supports our galaxy's structure extends nearly to the borders of neighbouring galactic systems. We are not separate observers of these cosmic processes, but intimate participants in them. Our bodies are made of stellar debris, our planet orbits within the galaxy's extended disk, and our consciousness might be the universe's way of appreciating its own vast, slowly unfolding beauty. This recognition transforms not just our understanding of galactic structure, but our sense of what it means to be human, to be conscious, to participate in the ongoing evolution of cosmic awareness itself. We are the universe becoming conscious of itself, one careful observation at a time. And if that doesn't fill you with a sense of cosmic wonder that extends far beyond the boundaries of our newly enlarged galactic home, then perhaps it's time to look up at that faint ribbon of light stretching across the night sky and remember that you're not just observing the Milky Way, you're living within it, breathing with it, participating in its ancient dance through space and time. The next time you find yourself questioning the nature of reality itself, wondering whether what we observe is somehow dependent on the consciousness that observes it, I invite you to explore these ideas further in our previous investigation. What if reality doesn't exist until you look at it? So where we dive even deeper into the mysterious relationship between consciousness and the cosmos we call home. But here's where our story takes its most profound turn. As we peer deeper into the structure of our cosmic home, something extraordinary begins to emerge from the data, patterns that seem to mirror the very process of observation itself. It's as if the galaxy is reflecting back to us the same mysterious relationship between observer and observed that quantum physicists have been grappling with for over a century. Consider this curious fact. The more precisely we try to measure the Milky Way's boundaries, the more those boundaries seem to shift and expand. Each new instrument reveals structures that were previously invisible. Each improvement in observational technique pushes the galactic edge further into what we once thought was empty space. It's almost as if the act of looking with greater precision creates the very structures we discover. Now, this isn't to suggest that our telescopes are literally creating stellar streams or dark matter halos. That would be a dramatic misunderstanding of how scientific observation works. But there's something deeply intriguing about the parallel between quantum uncertainty at the smallest scales and this apparent indefiniteness of galactic boundaries at the largest scales we can observe. In quantum mechanics, we've learned that particles don't have definite properties until they're measured. An electron exists in a superposition of possible states until our instruments force it to choose a specific position or momentum. Could it be that galaxies, in some sense, exist in a superposition of possible structures until we develop the observational capability to collapse that uncertainty into definite knowledge? This remains pure speculation, of course, with no scientific consensus supporting such an interpretation. But the philosophical implications are fascinating to contemplate. If consciousness does play some fundamental role in how reality manifests, and that's a very big if, then perhaps our evolving understanding of galactic structure represents a kind of cosmic meditation, a gradual awakening to truths that were always there, but required the right quality of attention to become visible. There's something almost organic about the way our galaxy reveals itself to patient observation. Those corrugated stellar structures we discovered, alternating above and below the galactic plane like cosmic breath patterns, suggest a living quality to our cosmic home that transcends mere mechanical processes. Ancient contemplatives often spoke of the universe as a vast breathing entity, expanding and contracting with rhythms too slow for human perception to directly grasp. Modern cosmology has discovered something remarkably similar in the expansion of space itself, and now we're finding these breathing-like patterns within our own galactic neighborhood. The gravitational waves that created these corrugated structures aren't just abstract mathematical descriptions of warped space-time. They represent actual undulations in the fabric of reality itself, ripples that have been propagating through our galaxy for billions of years. In a very real sense, the Milky Way has been breathing since long before Earth formed, and we're just now learning to feel its rhythm. This isn't mystical poetry, but measurable physics. Yet there's something profound about recognizing that we exist within these cosmic breath patterns, that our own biological rhythms are nested within galactic ones, which are themselves nested within the even vaster breathing of cosmic expansion and contraction. Some interpretations of contemplative practice suggest that aligning individual breath patterns with these larger rhythms can induce states of expanded awareness. While there's no scientific evidence that conscious breathing can directly influence galactic structure, there may be something valuable in the metaphorical recognition of our participation in these nested cycles of cosmic breath. Here we encounter one of the most beautiful paradoxes in all of science. We are the universe trying to understand itself, a collection of atoms organized in such a way that they can contemplate the very cosmic processes that created them. Every measurement we make of galactic structure is the Milky Way examining its own anatomy through the temporary lens of human consciousness. This creates a fascinating recursive loop. The galaxy creates conditions that allow for the emergence of complex chemistry. Complex chemistry enables the formation of living systems. Living systems evolve consciousness capable of astronomical observation. That consciousness then discovers that it lives within structures far more extended and mysterious than anyone previously imagined. But here's the truly remarkable part. Each discovery about galactic structure changes not just our knowledge, but potentially our relationship to the cosmos itself. When we learned that our galaxy is nearly twice as large as previously thought, we didn't just update a number in a textbook. We fundamentally altered our sense of home, our understanding of where we fit within the cosmic landscape. This suggests that consciousness and cosmos might be more intimately connected than our typical materialist worldview allows. Not in any provable scientific sense. We have no evidence that human thoughts can influence galactic evolution, but perhaps in the deeper sense that consciousness represents the universe's way of knowing and appreciating its own structure. Every time we look up at the night sky with wonder, every moment we spend contemplating the vast scales of cosmic architecture, we might be participating in something more profound than mere passive observation. We might be contributing to the universe's ongoing self-discovery, helping to bring into conscious awareness patterns and structures that existed as pure potential until observed with the right quality of attention. The instruments that revealed our galaxy's true size, spacecraft like Gaia with their micro-arc-second precision, infrared telescopes that peer through cosmic dust, spectrographs that decode the chemical fingerprints of distant stars, represent a kind of technological meditation on cosmic structure. Think about what Gaia actually does. For over a decade, this remarkable spacecraft has been practicing the most patient form of cosmic attention imaginable. It observes the same stellar fields repeatedly, measuring tiny shifts in position that reveal the three-dimensional architecture of our galactic neighborhood. It's like a mechanical monk devoted to a single, contemplative practice, pursued with superhuman consistency and precision. The data that emerges from such patient observation transforms our understanding not through dramatic revelations, but through the gradual accumulation of careful attention. Each measurement adds another point of light to our map of galactic structure. Over time, patterns emerge that no individual observation could have revealed. This mirrors something fundamental about contemplative practice itself. Insight rarely arrives through force or dramatic effort. Instead, it emerges from patient, sustained attention to what's actually present. The meditator who sits quietly, observing the breath for thousands of hours, gradually discovers subtleties that weren't accessible to hurried observation. Perhaps our technological instruments represent an extension of this contemplative approach to reality. We've created mechanical minds capable of the kind of sustained, precise attention that individual human consciousness can only approximate. Through these instruments, we participate in a form of cosmic meditation that transcends the limitations of biological perception. Those extended stellar structures we've discovered wrapped around our galaxy, the Monoceros Ring, the Triangulum Andromeda Stream, the corrugated patterns that stretch across hundreds of thousands of light years, aren't just collections of distant suns. They're memory made visible, the fossilized remnants of our galaxy's evolutionary history written in the positions and motions of individual stars. Each stellar stream tells the story of a smaller galaxy that was gradually torn apart by the Milky Way's gravitational influence. These weren't violent collisions, but slow-motion dances that unfolded over hundreds of millions of years. As the smaller galaxies spiraled inward, tidal forces stretched them into long trails of stars, that still trace their ancient orbital paths through space. In a very real sense, our galaxy remembers its past through the arrangement of its stellar components. The chemical compositions of different stellar populations record the conditions that existed when they formed. The orbital patterns of stellar streams preserve information about galactic encounters that occurred billions of years ago. This creates a beautiful parallel with human memory and consciousness. Just as our brains store memories through the arrangement of neural connections, our galaxy stores its history through the distribution of stars in space. Both systems, biological and galactic, use pattern and structure to preserve information across vast spans of time. Some interpretations suggest that this parallel isn't merely metaphorical. If consciousness is indeed a fundamental feature of reality rather than just an emergent property of complex brains, then perhaps galactic structure itself represents a form of cosmic memory, a way the universe preserves and processes information about its own evolution. This remains highly speculative, of course, with no scientific evidence supporting the idea that galaxies possess anything resembling consciousness or memory in the biological sense. But the metaphorical recognition of our participation in these cosmic patterns of information storage and processing can be profoundly meaningful for contemplative practice. Perhaps the most mysterious aspect of our galaxy's newly revealed structure involves the vast dark matter halo that extends nearly 2 million light-years from the galactic center. This invisible scaffolding contains roughly 5 times more mass than all the visible stars and gas combined, yet it reveals its presence only through gravitational effects on the matter we can directly observe. The parallel with consciousness is striking. In our everyday experience, conscious awareness seems to be just a small visible aspect of mental activity. Beneath the surface, thoughts and perceptions that we can directly access lies a vast unconscious realm that shapes our experience in ways we're only beginning to understand. Modern neuroscience suggests that conscious awareness represents perhaps 5% of total brain activity, remarkably similar to the proportion of visible matter to dark matter in cosmic structure. The vast majority of mental processing occurs below the threshold of conscious awareness, just as the vast majority of galactic mass remains invisible to our instruments. This parallel doesn't prove any scientific connection between consciousness and cosmic structure. Correlation isn't causation, and metaphorical similarity doesn't establish physical relationship. But it does invite us to consider whether there might be deep structural principles that govern complex systems at every scale, from neural networks to galactic architecture. Some contemplative traditions have long suggested that individual consciousness is like an iceberg, with only a small visible portion floating above the vast ocean of unconscious awareness. If this metaphor has any validity, then perhaps developing practices that expand conscious access to these deeper layers of mental activity mirrors the astronomical quest to map the dark matter structures that shape cosmic evolution. Standing beneath a truly dark sky, far from the light pollution of cities, you can see the Milky Way stretching from horizon to horizon, that faint ribbon of light that represents our edge on view through the galactic disk. But what you're seeing is only the tiniest fraction of the vast structure we've been exploring. The stellar streams that wrap around our galaxy 3 times, the corrugated patterns that extend hundreds of thousands of light years into space, the dark matter halo that reaches nearly to neighbouring galaxies. All of this remains invisible to naked eye observation. Yet it's all there, surrounding you, containing you, providing the gravitational foundation for everything you can see. This creates a profound shift in perspective. You're not just standing on a planet that orbits a star within a galaxy. You're embedded within layer upon layer of cosmic structure, each operating on scales that dwarf human imagination. The ground beneath your feet participates in orbital motions that carry you through stellar streams formed by galactic encounters that occurred billions of years ago. From this perspective, the boundary between self and cosmos becomes beautifully fluid. The elements in your body were forged in stellar nucleosynthesis and scattered through space by supernovae. The oxygen in your lungs has circulated through the galactic medium for millions of years before being incorporated into Earth's atmosphere. You breathe the exhalations of long-dead stars. Some interpretations suggest that recognizing this literal continuity between individual existence and cosmic structure naturally cultivates what contemplatives call cosmic consciousness, not as an abstract philosophical concept, but as a lived recognition of your participation in patterns that extend across space and time, scales beyond individual comprehension. The light reaching your eyes from the most distant parts of our galaxy left those stellar regions thousands of years ago, during the rise and fall of ancient civilizations on Earth. When you observe the galactic center, you're seeing it as it appeared when the first humans were developing agriculture. The extended stellar streams we've discovered show us the galaxy as it existed when complex life was just beginning to emerge on our planet. This creates a kind of temporal archaeology written in starlight. Each photon carries information not just about the star that emitted it, but about the cosmic conditions that existed when that light began its journey. By studying stellar populations at different distances, we can reconstruct the history of our galaxy's formation and evolution across billions of years. But here's where quantum mechanics introduces a fascinating wrinkle to this cosmic archaeology. According to some interpretations of quantum theory, the properties of those ancient photons aren't fully determined until they interact with our instruments in the present moment. The past, in some sense, remains open to influence by present observation. This doesn't mean we can change historical events through wishful thinking. That would be a dramatic misunderstanding of quantum mechanics. But it does suggest that the relationship between past and present might be more fluid than our everyday experience suggests. The information we extract from ancient starlight depends partly on the questions we choose to ask and the instruments we design to find answers. Some contemplative traditions speak of a similar fluidity in the relationship between memory and present moment awareness. Through mindful attention, we can sometimes discover new layers of meaning in past experiences, as if the present moment of observation somehow completes or clarifies what happened years or decades ago. Our solar system orbits the galactic center once every 225 million years, a period astronomers call a galactic year. During Earth's 4.5 billion year history, our planet has completed roughly 20 of these vast orbital circuits. Each galactic year carries us through different regions of the Milky Way structure, exposing our solar system to varying levels of cosmic radiation, stellar density, and gravitational influences. Some researchers have suggested that these galactic seasons might correlate with long-term patterns in Earth's geological and biological history. During portions of our orbit that take us through the galaxy's spiral arms, increased stellar formation and supernova activity might influence climate patterns and evolutionary processes on our planet. This remains speculative, with no scientific consensus supporting direct causal connections between galactic position and terrestrial evolution. but the possibility invites us to consider our planet's history within the context of these vast orbital rhythms that extend far beyond the solar cycles that govern weather and biological processes. From a contemplative perspective, there's something beautiful about recognizing that we participate not just in daily and seasonal cycles, but in galactic ones that unfold over timescales that encompass the entire history of complex life on Earth. Every breath we take occurs within the context of our slow orbital dance around the galactic center, a cosmic rhythm so vast that entire civilizations rise and fall between one galactic heartbeat and the next. Some meditation practices invite practitioners to expand their temporal awareness, resting attention not just in the immediate present but in progressively larger contexts of time. First the breath cycle, then the daily rhythm, then seasonal patterns, then the cycles of individual human life, and eventually the vast rhythms of cosmic evolution itself. One of the most intriguing aspects of our revised understanding of galactic structure involves the relationship between local and global properties. The same techniques that revealed our galaxy's extended size also showed that you can learn about the overall structure by carefully studying stellar populations in our immediate cosmic neighborhood. This mirrors something physicists have discovered about black holes and quantum information, the idea that information about a volume of space might be encoded on its boundary surface. In the galactic context, the properties of stars within a few thousand light years of our solar system carry information about processes that occurred across the entire galaxy over billions of years. The chemical compositions of nearby stars record the history of galactic chemical evolution. The orbital patterns of stellar streams in our neighborhood preserve information about galactic encounters that shaped structure across hundreds of thousands of light years. Local stellar populations serve as cosmic libraries that contain the story of galactic evolution written in atomic detail. This suggests that the universe might be structured holographically, with each part containing information about the whole. If this principle extends beyond physics into consciousness itself, and that's a very speculative if, then perhaps individual human awareness participates in something much larger than personal experience suggests. Some contemplative traditions have long claimed that careful attention to the contents of individual consciousness can reveal universal principles that apply across all scales of existence. While there's no scientific evidence supporting such claims, the holographic nature of cosmic structure does suggest that deep patterns might indeed repeat at multiple levels of organization. Our galaxy's extended structure raises fascinating questions about cosmic loneliness and connection. Milky Way multiple times, the dark matter halo that extends. Those stellar streams that wrap around the nearly 2 million light-years into space, all of this reaches toward our nearest large neighbour, the Andromeda Galaxy, which approaches us at 250,000 miles per hour across a gap that currently measures 2.5 million light-years. In cosmic terms, we're practically touching. The outermost reaches of our galaxy's dark matter halo might already be interacting with Andromeda's extended structure. What appears to be empty intergalactic space might actually be a region where two vast galactic systems overlap and interact in ways we're only beginning to understand. This creates a beautiful paradox of cosmic scale. On one hand, the distances between galaxies are so vast that individual stars within them will likely never directly interact, even when the galaxies eventually merge billions of years from now. The space between stars is simply too large, the likelihood of collision vanishingly small. Yet at the same time, the extended structures we have discovered suggest that galaxies aren't isolated islands in an empty cosmic ocean. They're connected through subtle gravitational influences, dark matter streams, and perhaps forms of cosmic relationship that remain invisible to current observational techniques. Some interpretations suggest that this paradox mirrors something fundamental about consciousness itself. Simultaneously isolated within individual experience, yet connected through patterns and processes that transcend personal boundaries. The contemplative recognition of this apparent paradox can be deeply meaningful, even if it has no basis in scientific fact. The ancient concept of celestial harmony, the idea that planetary motions create cosmic music, audible only to properly attuned consciousness, finds strange resonance in our modern understanding of galactic structure. Those gravitational waves that created our galaxy's corrugated disk patterns represent actual oscillations in space-time itself, frequencies so low that individual waves take millions of years to complete a single cycle. If you could somehow hear these cosmic frequencies, they would register far below the threshold of human perception, deeper than the lowest notes of any earthly instrument. Yet they're there, propagating through the fabric of space itself, carrying information about the massive objects and dynamic processes that generated them billions of years ago. Recent advances in gravitational wave astronomy have begun to make these cosmic songs audible to human consciousness through technological amplification. When two black holes spiral into each other, they create gravitational waves that can be detected by instruments sensitive enough to measure changes in distance smaller than 1,000th the width of a proton. The data from these detections can be converted into audio frequencies, allowing us to literally hear the sound of cosmic collisions that occurred billions of years ago in distant galaxies. We're developing the technological equivalent of cosmic hearing, the ability to perceive frequencies that extend far beyond biological sensation. This technological expansion of perceptual capability might represent a form of evolutionary development, consciousness learning to participate in ever larger scales of cosmic pattern and information. Through our instruments, we're beginning to hear the music of the spheres that ancient philosophers could only imagine. What emerges from all these discoveries is something that might be called contemplative astronomy, an approach to cosmic observation that recognizes the observer as an integral part of what's being observed. This doesn't mean abandoning scientific rigor or objective measurement. Rather, it involves acknowledging that consciousness and cosmos co-evolve together in ways that pure materialism might not fully capture. The patient attention required for astronomical observation mirrors contemplative practice in profound ways. Both require sustained focus, willingness to be surprised by what reveals itself, and recognition that reality is always more complex and beautiful than our initial assumptions suggest. The instruments we've developed, spacecraft that maintain precise attention for decades, telescopes that gather light with mechanical patience, spectrographs that decode stellar chemistry with superhuman precision, represent extensions of contemplative awareness into cosmic scales. Through these technological minds, human consciousness participates in forms of cosmic meditation that individual biological perception could never achieve. This perspective doesn't require any unproven claims about consciousness influencing cosmic structure. It simply recognizes that the process of cosmic discovery involves a dynamic relationship between the observer and the observed, a dance of attention and revelation that transforms both our understanding of the universe and our sense of what it means to be conscious within it. Some interpretations suggest that this contemplative approach to cosmic observation might be more than just poetic metaphor. If consciousness does play some fundamental role in how reality manifests, and that remains highly speculative, then perhaps our evolving understanding of galactic structure represents a form of cosmic awakening, the universe gradually becoming conscious of its own vast, beautiful, and mysterious architecture. As our observational capabilities continue to expand, we can expect even more dramatic revisions to our understanding of cosmic structure. The next generation of space telescopes will peer deeper into space and time, revealing how galaxies like ours formed from the primordial fluctuations that emerged shortly after the Big Bang. Quantum technologies might eventually allow us to detect gravitational effects that are currently beyond our measurement capabilities. Advanced AI systems could discover patterns in cosmic data that human consciousness cannot directly perceive. We might develop forms of technological consciousness that can maintain attention across timescales that encompass entire galactic evolutionary cycles. Perhaps most intriguingly, advances in our understanding of consciousness itself might reveal new connections between awareness and cosmic structure. If consciousness is indeed more fundamental to reality than current materialist science assumes, then our relationship to the cosmos we observe might be far more intimate and participatory than we currently imagine. This remains pure speculation, of course, with no scientific consensus supporting such possibilities. But the rapid pace of discovery in both observational astronomy and consciousness research suggests that our understanding of these connections will continue to evolve in surprising ways. What seems certain is that the universe will continue to reward patient, careful attention with insights that transform our understanding of our place within it. Each generation of observers discovers that reality is stranger, more beautiful, and more mysterious than their predecessors imagined. Perhaps the deepest teaching that emerges from our galaxy's size revision involves the infinite nature of cosmic mystery itself. Each answer we discover opens onto deeper questions. Each measurement reveals new layers of complexity. Each expansion of perspective unveils even vaster scales of structure and beauty. This isn't a failure of scientific method, but perhaps its greatest achievement: the recognition that reality appears to be inexhaustibly rich, always ready to surprise us with new depths of pattern and meaning. The contemplatives, who spoke of ultimate truth as infinitely mysterious, might have been describing not just a spiritual insight, but a literal feature of cosmic architecture. The galaxy that seemed so familiar, so well understood, revealed itself to be twice as large as we thought, and structured in ways that nobody predicted. If we can be so fundamentally wrong about something as basic as the size of our cosmic home, it raises profound questions about the nature of knowledge itself and our capacity to truly understand the reality we inhabit. Yet this isn't cause for skepticism about scientific discovery, but rather an invitation to approach reality with what contemplatives call beginner's mind, a willingness to be surprised, to have our assumptions overturned, to discover that the universe is always stranger and more wonderful than we imagined. The recursive nature of cosmic wonder suggests that consciousness and cosmos might be perfectly matched to each other. Reality structured in such a way that awareness can never exhaust its depths, and consciousness organized in such a way that it can appreciate ever greater scales of cosmic beauty and mystery. As we near the end of our journey through the revised understanding of our cosmic neighborhood, it's worth returning to that simple experience of standing beneath a dark sky and gazing up at the Milky Way, stretching from horizon to horizon. What you see in that moment, that faint ribbon of light composed of billions of distant suns, represents only the tiniest visible fraction of the vast structure we've been exploring. The extended stellar streams, the corrugated disk patterns, the dark matter halo that reaches nearly to neighbouring galaxies, all of this surrounds you, contains you, provides the gravitational foundation for everything you can perceive. But perhaps more importantly, you are not separate from these cosmic structures. You are made of stellar debris. You breathe the processed exhalations of supernova. You participate in gravitational patterns that extend across millions of light years of space. The boundary between self and galaxy is far more fluid than everyday experience suggests. This recognition doesn't require any mystical beliefs or unproven scientific claims. It's simply the literal truth of our cosmic situation. We are intimately woven into the fabric of galactic structure at every level, from the atomic to the astronomical. Our existence represents the universe becoming conscious of itself through temporary arrangements of stellar matter organized into living, aware systems. From this perspective, the study of galactic structure becomes a form of cosmic self-knowledge, consciousness exploring its own vast, beautiful, and mysterious architecture. Each measurement we make, each discovery we celebrate, each moment of wonder we experience while contemplating cosmic scales contributes to the universe's ongoing self-discovery. The corrugated disk of our galaxy continues to breathe with gravitational waves that have been propagating since before complex life emerged on Earth. The stellar streams that wrap around our cosmic home carry the memory of ancient galactic encounters. The dark matter halo that supports our galaxy's structure extends into realms so vast that light takes millions of years to cross them. And within all of this cosmic immensity, consciousness has somehow emerged, not as an accident or afterthought, but perhaps as an integral feature of how reality knows and appreciates its own infinite depths of pattern and beauty. This is our galactic home, far stranger and more wonderful than we ever imagined, yet perfectly designed for the emergence of awareness capable of appreciating its own cosmic context. We are the Milky Way dreaming about itself, temporary whirlpools of organized matter and energy through which the universe explores its own vast, mysterious, and inexhaustibly beautiful nature. If these explorations into the mysterious relationship between consciousness and cosmic structure have sparked your curiosity, you might find even deeper insights waiting in our previous investigation. What if reality doesn't exist until you look at it? Where we dive into the profound implications of quantum mechanics for our understanding of existence itself, and discover that the very act of observation might play a far more fundamental role in shaping reality than our everyday intuition suggests. The next time you find yourself beneath a clear night sky, gazing up at that ancient river of light we call the Milky Way, remember that you're not just observing our galaxy, you're living within it, breathing with it, participating in its slow dance through space and time. You're made of its processed starlight, shaped by its gravitational embrace, and perhaps most remarkably of all, you've become its way of knowing itself. In a universe where galaxies can reveal themselves to be twice as large as we thought, where stellar streams wrap around cosmic structures in patterns we never predicted, where dark matter halos extend into realms that touch neighbouring galactic systems, perhaps the most extraordinary discovery of all is this: consciousness itself has emerged from these cosmic processes, creating minds capable of appreciating the vast, beautiful mystery of our place within it all. The Milky Way stretches nearly 200,000 light-years across its extended disk, breathes with gravitational waves that have been propagating for billions of years, and remembers its history through the arrangement of stellar streams that trace ancient galactic encounters. And somehow, within this cosmic immensity, you exist, a temporary pattern of organized matter that has learned to contemplate the very processes that created it. That's not just astronomy, that's the universe awakening to its own infinite depths of wonder, one careful observation at a time. This exploration of galactic consciousness and cosmic contemplation represents speculative connections between established astronomical discoveries and contemplative philosophy. While the scientific discoveries about the Milky Way's size are well documented, any suggestions about consciousness playing a role in cosmic structure remain unproven and should be understood as philosophical speculation rather than established scientific fact. Picture this. Right now, as you sit quietly reading these words, trillions of quantum particles are dancing through your body in states of pure possibility. They exist everywhere and nowhere simultaneously, waiting for something or someone to collapse their infinite potential into definite reality. For over a century, physicists have known that the quantum world behaves in ways that seem to defy logic. But what they're just beginning to explore is whether the ancient practice of meditation might offer a unique window into these mysterious quantum processes. What if the contemplatives were right all along? What if consciousness isn't just an accidental byproduct of complex chemistry, but something far more fundamental, a participant in the very fabric of reality itself? Recent discoveries at the intersection of quantum physics and neuroscience are revealing connections that sound like science fiction, but rest on surprisingly solid experimental ground. Let's begin with something every meditator knows intimately: the present moment. It seems simple enough. This immediate experience of nowness that contemplatives have been exploring for thousands of years. But from a quantum perspective, the present moment is far stranger than our everyday intuition suggests. In classical physics, time flows like a river, carrying us from past through present into future in an orderly sequence. But quantum mechanics reveals something much more mysterious. At the smallest scales of reality, particles don't follow definite paths through time. Instead, they exist in what physicists call superposition, a ghostly state where all possible histories coexist simultaneously until the moment of observation collapses them into a single, definite outcome. This isn't just abstract theory. When electrons pass through the famous double-slit experiment, they somehow go through both slits at the same time, creating an interference pattern that's only possible if the particle exists in multiple states simultaneously. It's only when we try to measure which slit the electron actually passed through that this quantum superposition collapses into classical, definite reality. Now, here's where things get intriguingly contemplative. Meditation teachers have long spoken of the present moment as the only point where reality actually exists, past and future being mental constructions that exist only in memory and imagination. Could it be that contemplatives have been intuitively recognizing something that quantum physics has now made explicit? That reality isn't a fixed backdrop against which events unfold, but something more fluid, more participatory. Some interpretations suggest, and I want to emphasize that this remains highly speculative, that consciousness might play a role in the collapse of quantum superposition. Not in any magical or mystical sense, but through the simple act of observation. When we pay attention, when we truly observe what's happening in this moment, we might be participating in the ongoing creation of definite reality from quantum possibility. This doesn't mean your thoughts control the universe. That would be a dramatic misunderstanding of both quantum mechanics and contemplative practice. But it does suggest that the relationship between mind and reality might be more intimate than our materialist worldview typically acknowledges. The observer effect in quantum mechanics states that the act of measurement fundamentally alters what's being measured. This isn't because our instruments are clumsy or intrusive, but because measurement itself appears to be a creative act that helps determine which of many possible outcomes becomes actual reality. Now consider what happens during meditation. You're not trying to change anything or achieve any particular state. You're simply observing, watching the breath, noticing thoughts as they arise and pass away, paying attention to sensations in the body. It's the purest form of observation possible, awareness witnessing its own contents without agenda or interference. Could there be a connection between the quantum observer effect and this contemplative practice of pure observation? Some researchers are beginning to explore this possibility, though we're still in the earliest stages of understanding what such a connection might mean. Dr. Stuart Hameroff and Sir Roger Penrose have proposed that consciousness might emerge from quantum processes within the microtubules of brain cells. While this remains controversial and lacks scientific consensus, their work suggests that the boundary between quantum and classical reality might exist right at the threshold, where neural activity gives rise to conscious experience. If consciousness does involve quantum processes, and that's a significant if, then meditation might represent a practice of learning to observe these quantum events directly, not through external instruments, but through the refined attention that contemplative training develops. This would explain something that experienced meditators often report, a sense that consciousness becomes more fundamental, more primary, the deeper the practice goes. Instead of feeling like a small awareness trapped inside a physical body, practitioners often describe expanded states where consciousness feels more like the space in which all experience arises. From a quantum perspective, this shift might reflect a movement from classical to quantum modes of awareness, from experiencing yourself as a separate observer of reality to recognizing yourself as a participant in reality's ongoing self-creation through the act of conscious observation. Quantum entanglement might be the strangest phenomenon in all of physics. When two particles become entangled, they remain mysteriously connected regardless of the distance separating them. Measure the spin of one particle and its entangled partner instantly assumes the opposite spin, even if it's on the other side of the universe. Einstein famously called this spooky action at a distance because it seemed to violate the principle that nothing can travel faster than light. But decades of experimental verification have confirmed that entanglement is real, measurable, and fundamental to how quantum reality operates. Now here's what makes this relevant to contemplative practice. Experienced meditators often report a direct sense of interconnection with all life, all existence. This isn't just a beautiful philosophical idea, but a lived experience that feels as real and immediate as any other perception. Buddhist teachings speak of interdependence, the recognition that all phenomena arise in dependence upon countless causes and conditions, with no truly independent existence. Hindu Advaita points toward a fundamental unity underlying the apparent diversity of experience. Mystical traditions across cultures describes states of consciousness where the boundaries between self and world dissolve into seamless wholeness. Could these contemplative insights be reflecting something literal about the quantum structure of reality? We have no scientific evidence that human consciousness can directly experience quantum entanglement, but the parallel is intriguing to contemplate. Some interpretations suggest that if consciousness does emerge from quantum processes in the brain, then perhaps the sense of interconnection that arises in deep meditative states reflects a kind of neural entanglement, not with distant particles, but with the quantum field that underlies all of manifest reality. This remains pure speculation, of course, with no experimental verification, but it offers a fascinating bridge between the mystical experiences reported by contemplatives and the strange interconnectedness that quantum physics has discovered at the foundation of the physical world. The measurement problem in quantum mechanics asks a deceptively simple question. Exactly when and why does quantum superposition collapse into definite reality? We know it happens when we make a measurement, but what counts as a measurement? Does it require a conscious observer, or is any physical interaction sufficient? This question has divided physicists for nearly a century. The Copenhagen interpretation suggests that consciousness might play a crucial role. The many worlds interpretation claims that all possibilities remain real in parallel universes. The objective collapse theories propose that the wave function collapses spontaneously based on physical processes alone. But here's where contemplative practice offers a unique perspective on this ancient debate. Meditation involves training attention to become increasingly subtle and precise. Advanced practitioners report being able to observe the arising and passing away of mental events with extraordinary clarity, watching thoughts emerge from emptiness, develop through various stages, and dissolve back into the space of awareness. Could this refined attention be developing sensitivity to quantum processes that normally remain below the threshold of conscious awareness? Some researchers are investigating whether meditators might be able to observe the collapse of quantum superposition directly through the trained introspection that contemplative practice develops. Dr. Deepak Chopra and physicist John Hagelin have suggested that consciousness operates at the quantum level, though their claims remain controversial and lack peer-reviewed experimental support. More cautiously, researchers like Dr. Stuart Hameroff continue investigating whether quantum coherence in microtubules might contribute to conscious experience. What we can say with more confidence is that meditation definitely changes brain activity in measurable ways. Long-term practitioners show increased grey matter density in areas associated with attention and sensory processing. They demonstrate enhanced ability to maintain focused attention and reduced activation in brain networks associated with self-referential thinking. Whether these changes reflect increased sensitivity to quantum processes remains an open question, but the possibility suggests that contemplative practice might represent a form of consciousness research that complements the external instruments of physics, a way of investigating the relationship between mind and reality from the inside out. In quantum physics, coherence refers to the degree to which quantum particles maintain synchronized wave functions. When particles are coherent, they behave collectively rather than individually, creating effects that transcend what any single particle could accomplish alone. Laser light provides a perfect example of quantum coherence in action. Ordinary light consists of photons oscillating at random phases, creating incoherent illumination. But in a laser, all the photons oscillate in perfect synchrony, creating coherent light that can cut through steel or transmit information across vast distances. Some interpretations suggest that consciousness might involve similar, coherent states in the brain. If neurons can maintain quantum coherence across larger scales than typically expected, it might explain how millions of individual brain cells give rise to unified conscious experience. This connects intriguingly with reports from advanced meditators about states of profound inner coherence. In the deepest stages of meditative absorption, practitioners describe awareness becoming perfectly unified. No sense of separation between observer and observed. No fragmentation of attention across different mental contents. Dr. John Hagelin, a quantum physicist who also practices transcendental meditation, has proposed that these unified states reflect direct experience of what physicists call the unified field, the theoretical foundation from which all the forces and particles of nature emerge. While this interpretation lacks scientific consensus, it points toward fascinating parallels between the unity discovered in contemplative states and the underlying coherence that quantum field theory reveals at the foundation of physical reality. Neuroscientist Dr. Richie Davidson's research at the University of Wisconsin has shown that experienced meditators exhibit extraordinary coherence in their brainwave patterns during deep meditative states. Gamma wave activity associated with heightened awareness and integration shows levels of synchronization far beyond what's typically observed in ordinary consciousness. Whether this neural coherence reflects quantum effects remains unclear, but it suggests that contemplative practice might be developing forms of consciousness that operate according to principles similar to those governing quantum coherence, collective behavior that transcends individual components to create emergent properties of extraordinary power and beauty. One of the most profound discoveries of modern physics is that empty space isn't actually empty. The quantum vacuum seethes with virtual particles, constantly energy field that permeates all of reality, popping into and out of existence, creating a background. This quantum vacuum isn't a void, but a plenum, an infinitely creative potential from which all manifest phenomena emerge and into which they eventually dissolve. It's the womb of the universe, the source and ground of everything that exists. Contemplatives have long pointed toward a similar recognition about the nature of consciousness itself. In meditation, when the mind becomes very still and all mental content settles, what remains isn't unconsciousness or a blank void. Instead, practitioners report discovering a luminous emptiness, aware space that's simultaneously empty of objects, yet full of the potential for any experience to arise. Zen teachers call this original face before your parents were born. Hindu Advaita points toward it as pure consciousness, the aware space in which all experience appears and disappears like waves on the ocean. Buddhist meditation explores it as the clear light nature of mind that underlies all mental activity. Could this empty awareness that contemplatives discover be somehow connected to the quantum vacuum that physicists have found at the foundation of physical reality? This remains pure speculation, but the parallel is striking enough to warrant serious consideration. Some interpretations suggest that consciousness might be more fundamental than matter, not emerging from complex arrangements of particles, but serving as the field within which particles appear. If this perspective has any validity, then the empty awareness discovered in meditation might reflect direct recognition of the same creative potential that quantum field theory describes in mathematical terms. Dr. Amit Goswami, a quantum physicist who has written extensively about consciousness and quantum mechanics, proposes that consciousness is the ground of being from which both mind and matter emerge. While his ideas remain outside mainstream physics, they point toward a possible resolution of the hard problem of consciousness, the mystery of how subjective experience arises from objective physical processes. Whether or not such interpretations prove correct, the parallel between quantum vacuum and empty awareness suggests that contemplative and scientific investigations might be exploring the same fundamental mystery from complementary perspectives. Bell's theorem and the experimental violations of Bell's inequalities have demonstrated that quantum reality is fundamentally non-local. This means that the properties of quantum particles cannot be determined by local hidden variables. There's something about quantum systems that transcends the classical boundaries of space and time. This non-locality doesn't mean that quantum effects can be used to send faster-than-light messages or influence distant events through conscious intention. The correlations revealed by quantum entanglement are statistical and cannot be controlled by any local observer. But it does mean that the universe is far more interconnected at its foundation than classical physics ever suggested. Advanced contemplative states often involve similar transcendence of spatial and temporal boundaries. Practitioners report experiences where the usual sense of being located at a particular point in space and time dissolves into awareness that seems to encompass everything simultaneously. These aren't hallucinations or altered states in the pathological sense, but rather shifts in the mode of consciousness that reveal aspects of reality normally hidden by the filters of ordinary perception. The boundaries between self and world, between here and there, between now and then, become permeable or disappear entirely. Could these contemplative experiences of non-local awareness be reflecting the same fundamental non-locality that quantum physics has discovered? We have no experimental evidence that human consciousness can directly experience quantum non-locality, but the phenomenological parallels are intriguing. Some interpretations suggest that if consciousness does emerge from quantum processes, then perhaps the dissolution of spatial and temporal boundaries in deep meditative states reflects a kind of expansion beyond the classical limitations that normally constrain awareness to specific locations in space and time. This would explain why contemplatives throughout history have described experiences of omnipresence, not as supernatural powers, but as natural capacities that emerge when consciousness learns to operate according to its deepest nature, rather than the habitual patterns that create the illusion of separation. Geoffrey Chew's bootstrap theory in particle physics proposed that the universe might be self-consistent. No fundamental particles or forces, but rather a web of relationships where every component depends on every other component for its existence. The universe bootstraps itself into existence through pure self-consistency. While bootstrap theory hasn't become the dominant paradigm in physics, it points toward a fascinating possibility that reality might be fundamentally self-referential, a system that creates and maintains itself through its own internal relationships. This connects remarkably with both ancient contemplative insights and modern theories about consciousness. The universe isn't just a collection of objects observed by separate subjects, but a self-aware system where consciousness and cosmos co-evolve together. From a contemplative perspective, the deepest realization often involves recognizing that the awareness observing experience isn't separate from experience itself. The observer, the process of observing and the observed are revealed as different aspects of a single, seamless reality. Some interpretations suggest that this contemplative insight might reflect a literal truth about cosmic structure. If consciousness is fundamental rather than emergent, then perhaps the universe is intrinsically self-aware, not because it contains conscious beings, but because consciousness is the very medium within which cosmic evolution unfolds. Dr. Stuart Kauffman, a complexity theorist, has proposed that the universe might be poised at the edge between order and chaos, a condition that naturally gives rise to increasing complexity and eventually consciousness. The universe doesn't just happen to contain awareness, it evolves toward ever greater self-knowledge. This would explain why contemplative practice often leads to experiences of cosmic consciousness, not as escape from ordinary reality, but as recognition of the self-aware nature of reality itself. When individual consciousness expands beyond personal boundaries, it might be discovering its fundamental continuity with the cosmic intelligence that guides evolution at every scale. Quantum tunneling allows particles to pass through energy barriers that should be impossible to cross according to classical physics. An electron can tunnel through a wall not by going over or around it, but by essentially disappearing on one side and reappearing on the other without ever existing in the space between. This isn't just theoretical curiosity. Quantum tunneling is essential for nuclear fusion in stars, the operation of electronic devices, and countless other processes that make life possible. Reality routinely transcends the limitations that classical logic would impose. There's a fascinating parallel here with the way insight arises in contemplative practice. Practitioners often struggle with particular obstacles, persistent mental habits, emotional patterns, or conceptual limitations that seem impossible to overcome through gradual effort. Then suddenly, understanding leaps across the barrier in a way that bypasses logical progression. The insight doesn't arrive through step-by-step reasoning, but appears instantaneously, complete and transformative. Buddhist literature calls these moments sudden enlightenment, recognition that transcends the gradual path entirely. Could contemplative insights involve something analogous to quantum tunneling? Not in any literal sense. We have no evidence that thoughts or awareness can tunnel through barriers in the same way that particles do. But perhaps the non-linear nature of contemplative realization reflects the same fundamental principles that allow quantum systems to transcend classical limitations. Dr. Amit Goswami has suggested that creative insights in science, art, and spiritual practice might involve quantum jumps in consciousness, discontinuous leaps that bypass the logical mind and deliver understanding that couldn't have been reached through incremental thinking alone. While such ideas remain speculative, they point toward an intriguing possibility that consciousness might operate according to quantum rather than classical principles, allowing for sudden transformations that transcend the limitations of ordinary mental processing. Schrödinger's famous thought experiment placed a cat in a quantum superposition of being simultaneously alive and dead until observed. He intended this as a critique of quantum mechanics, showing how strange quantum effects become when extended to macroscopic objects. But perhaps Schrödinger's cat offers a perfect metaphor for the nature of personal identity as revealed through contemplative practice. In ordinary consciousness, we feel like solid, continuous selves with definite characteristics and clear boundaries. But meditation reveals something much more fluid. Advanced practitioners often report that the sense of being a separate self, what Buddhism calls the ego illusion, exists in a kind of superposition. Sometimes it appears solid and convincing, other times it dissolves entirely, and often it exists in ambiguous states between definite presence and complete absence. The self isn't there or not there in any fixed way. Instead, it exists as a probability wave that collapses into apparent solidity when observed with ordinary habitual attention, but reveals its insubstantial nature when examined with the refined awareness that meditation develops. This doesn't mean personal identity is entirely illusory. That would be spiritual bypassing of the worst kind. Rather, it suggests that selfhood is more like a quantum phenomenon than a classical object, existing in relationships and contexts rather than as an independent entity with inherent characteristics. Dr. Thomas Metzinger's research on the phenomenal self model suggests that what we experience as self is actually a sophisticated neural construction, a model that the brain creates to organize experience, but which has no substantial existence independent of the modeling process itself. From this perspective, contemplative practice might involve learning to observe the construction of selfhood in real time, watching how the sense of being a separate self emerges and dissolves moment by moment through the activity of consciousness itself. Niels Bohr's principle of complementarity states that quantum objects have pairs of properties that cannot be measured simultaneously. You can measure either the position or the momentum of a particle, but not both at the same time. These aren't limitations of our instruments, but fundamental features of quantum reality itself. Wave and particle represent the classic example of complementarity. Light behaves as a wave when we design experiments to detect its wave nature, and as a particle when we look for its particle nature. Both descriptions are correct, but they're mutually exclusive ways of understanding the same underlying quantum reality. Contemplative traditions have long recognized a similar complementarity in approaches to understanding consciousness and reality. You can analyze experience intellectually, breaking it down into components and relationships, or you can rest in direct awareness that transcends conceptual categories entirely. Both approaches reveal important truths, but they cannot be pursued simultaneously. Buddhist philosophy distinguishes between conventional truth, samutesakha, and ultimate truth, paramathasakha. Conventional truth includes all the practical, relative ways we understand reality through language, concepts, and everyday experience. Ultimate truth points toward a direct recognition of how things actually exist beyond conceptual overlay. These aren't contradictory truths, but complementary perspectives on the same seamless reality. Sometimes it's skillful to engage the conventional level, planning, thinking, relating to the practical dimensions of existence. Other times, wisdom involves releasing conceptual frameworks entirely and resting in pure awareness. Could this contemplative complementarity reflect the same fundamental structure that quantum physics has discovered in the relationship between different ways of observing reality? Some interpretations suggest that consciousness itself might be governed by complementarity principles, capable of existing in different modes that reveal different aspects of its nature. The quantum Zeno effect demonstrates that frequent observation can actually freeze quantum evolution. If you measure a quantum system repeatedly, you can prevent it from changing state. The act of observation itself becomes a controlling influence on quantum behavior. This effect has been experimentally verified in numerous quantum systems. Particles that would normally decay or evolve can be held in stable states through sufficiently frequent measurements. Observation doesn't just passively record quantum events, it actively participates in determining their evolution. There's a striking parallel here with contemplative practices that involve sustained attention. Mindfulness meditation, for example, involves maintaining continuous awareness of present moment experience. Instead of getting lost in mental commentary or emotional reactivity, practitioners learn to observe thoughts and sensations with steady, non-judgmental attention. Experienced meditators often report that this quality of sustained observation has a stabilizing effect on consciousness itself. Mental states that would normally change rapidly, emotions, thoughts, even physical sensations, tend to become more stable when observed with consistent, mindful attention. So here we are, at the edge of one of the most beautiful mysteries science has ever encountered. We've explored the strange parallels between quantum mechanics and contemplative practice, walked through the implications of observer effects and quantum coherence, and contemplated what it might mean if consciousness plays a more fundamental role in reality than we ever imagined. The honest truth is that we're still in the earliest stages of understanding these connections. The scientific evidence remains preliminary, often controversial, and always evolving. But what's undeniable is this: the deeper we look into the quantum world, the more it starts to look back. And maybe, just maybe, what we're really exploring is ourselves. We're really exploring is ourselves.